Hello everyone. Today let's solve the problem computer game. So this was asked in educational code forces round 115 rated for the division 2, right? So this was basically asked in educational code forces round 115, right? So let's see what the question states. You can just go through the question. It's very easier to understand, right? So I'll just summarize the question so that it will be easier for us to solve the problem. So just give me a second here. 1 second. Yeah. So here Monocorp plays a game on a 2 into n grid. There is a guy called Monocorp, so I'll just write him MC. So Monocorp plays a game on a 2 into n grid. On a 2 into n grid. Just keep this in mind. So he starts at the top left cell. He starts, suppose I'll just take 2 into 2 grid here. So he starts at the top left cell, this one they are speaking of, right? He starts at the top left cell 1 comma 1 and wants to reach the bottom cell 2 comma n, this one. Bottom cell means 2 comma n means this one, right? So marked as 0. Marked as 0. So here in this case he starts at the top cell 1 comma 1 and wants to reach the bottom right cell 2 comma and he can move in 8 directions. So he can move in 8 directions, so we can backtrack, right? So he can move in any of the 8 directions they have given. So we can backtrack here, we can just make use of the backtrack along with the dfs with backtracking. So you would have already guessed, we can make use of the dfs with the backtracking, right? So he can move in 8 directions including the diagonals. He can move including the diagonals they have given. There is nowhere written that he has to move left, right, up and down. So that is done by the dfs, and also they have given he can move diagonally as well. So it is not a problem for him. So he can move in 8 directions including diagonals to adjacent safe cells marked 0. To adjacent safe cells marked 0. Cells marked 1 are traps. So cell that is marked as 1 are traps basically, right? So cell which is marked as 1 are traps. Just remember this one. This is very important part, right? So cells marked 1 are traps. Stepping on them ends the game. Stepping on this one. Stepping on the cell 1, this one ends the game. Stepping on them ends the game. What we need to do then here, we need to determine if there is a path from 1 comma 1 to 2 comma n, means here from top left cell, this one I'm speaking of. From, just give me a second, let me change the color so that uh, oh, I did this one, this is fine. Anyways, we have this one. We have to determine if there is a path from here, this one, from path 1 comma 1 to 2 comma and they have considered here 1, we are considering 0 from 0, right? 0 comma 0, they have considered 1 index, we are considering from 0 comma 0 here cell, this one, right? So don't get confused here. So they are saying here we have to determine if there is a path from 1 comma 1 to 2 comma n, this one, the last one, 2 comma n, without touching any traps. Without touching any traps means if there is one, if there is one in the cell, this one we need to ignore, right? This one we need to ignore. He can move in any of the 8 directions. He can move left, right, this one, diagonally, anywhere. He can move any of the 8 directions, right? So that's what they have given in the questions, and we have to ignore this part 1. We shouldn't touch the trap where 1 is present. 1 is a trap. 1 is considered as a trap, and stepping on 1 ends the game. Just keep this in mind. Stepping on 1 ends the game. Ends the game, right? So we have to determine if there is a path from this one 1 comma 1, nothing but 0 comma 0. In our case we are going with a 0 index, right? So here in this case we have to determine if there is a path from 1 comma 1 to 2 comma n, means the last one. This is nothing but the 2 comma n, the last one, right? Without touching any traps. Without touching any traps, we have to ignore the trap, right? So we have to ignore the trap. So this is what the question states. Very easier to understand, right? Let's come to the input part here. So in this case, we have been given n equals 3. We have been given n equals 3. Total 4 inputs we have. Total 4 inputs we have for the first, this one, for the first example. This one 4 inputs, 3. This one, this is the first input, and this is the second input, and this is the third input, and this is the fourth input. So let's consider the first one, and same goes with the second, third, and fourth as well. So for the approach also, I'll be considering the first, usually the first input itself, or the first example I'll be considering most of the time, so that you can just, I insist you to try out with the second one, third one, or the fourth one if it exists. Second one, quite obviously they would be giving at least two inputs, right? Two inputs or the three inputs. for every problem. So I insist you to try out the same with the second or the third example so that you understand the problem clearly, right? So here in this case, the first input consists of 3, and this is nothing but the row 1. Triple zero they have given, right? 000. This is nothing but the row 1, and the second one triple zero, what they have given here, 000. This is row 2. This is row 1, and this is nothing but row 1000, and this is nothing but this triple zero is nothing but the row 2. Row 2, right? So this 3 what they have given, this 3 is nothing but the n. This is n, and this is row 1, and this is row 2. Row 1 and row 2, right? So 3 numbers here in this case, triple zero, this one. We have two rows, nothing but 2 rows and 3 columns, basically 000 000, right? So I hope this part is completely clear, man. First, for the first one, the output that we need to get here is yes, means there is a path from 1 comma 1 to 2 comma n without touching any trap, so we are returning s here. Same goes with the second input s. For the third input, for this one, for 0 triple 1 triple 1 0, you can clearly see from 0 you have to hop to 1 at any cost, left, right, diagonally, anywhere. So you have to touch the trap, you have to touch the trap at any cost here. By looking at it, by looking at this, you can say that it is not possible, so we have to return no, right? So for the six, this one, fourth input, they have given 6 columns here. This one, 0 1 0 1 0 1, right? So this is nothing but the number of columns, man. 3 they have mentioned, basically n they have given here, and we have again 2 rows and 6 columns here. 0 1 0 1 0 1 1 0 1 0 1 0. It is possible, right? It is possible. 0 0 diagonally he can move, right? So here in this case, for the first one, diagonally he can move, and yeah, same goes with all the things. He can move diagonally as well. They have strictly mentioned by moving diagonally he can reach the 0 from this one, 1 comma 1 to this one, what do we call, 2 comma n. So this is possible, so we have to return again s. So simple one. This is very simple problem. Basically, what we'll be doing. So this is about the input, output, and the question. So basically, what we'll be doing. We will be going with the this one, recursive DFS, or the DFS with the backtracking. Right. So we will be mainly we will be making use of the backtracking here. Backtracking DFS with backtracking. DFS with backtracking. Just keep this in mind. DFS with backtracking. So this is the approach that we'll be going with. So let's discuss the approach followed by the complexities, and then let's write the code, right? So as usual, first let's discuss the approach. So here I have considered the same first example that they've given in the question here. Nothing but this is n is 3, this is nothing but the row 1, and this is nothing but the row 2. We have 3 columns, right? So n we have been given 3 here. So first thing that we need to note down here is we will be going with the backtracking approach along with the DFS, right? DFS backtracking. DFS along with the backtracking. We can move in 8 directions that they have given in the question. We can move in 8 directions that they have given in the question already. The output that we need to get here is yes, because we have 0, we don't have 1 at all, man. By looking at the input itself, you can just say that he can either move this one to right, or even bottom, or he can move diagonally as well to reach this one. He can reach easily, step by step, right? He can reach easily. Monocop can reach from 1 comma 1 to n, this one 2 comma n easily, while we consider this example. That is the reason I'm insisting I am insisting you to try out with a different example so that you understand this one crystal clear, right? So there are ones given in the example as well in the other input, so that you understand things better. You'll get to know your intuition may be this thing, may be different, right? So you can just write the code better than me in that case, right? So here in this case, we have n, we have row 1 and row 2. The output that we need to get here is yes. By looking at it, by looking at the input itself, we can say that a monocop can reach, right, from 1 comma 1 to 2n, means from first this one row to the last one, the last, from first cell to the last cell, in simple terms, right? So let's move on with the step by step explanation here. So here monocop starts from here, right? So basically n we have been given 3, row 1 and row 2. This is nothing but the row 1 and row 2. All the values we have is 0 here. All the values are 0 in the cell, right? So let's move on with the first step here. We will start at 0 comma 0, nothing but first row, first column. This one I'm speaking, this is first row and first column. This is first row and first column. So we have to move to 0 comma 1 0 comma 2, or diagonally to 1 comma 1, etc., right? So either we can move here, either we can move 1 comma 0 or to 1 comma 1 diagonally also we can move. That's what they have given, right? So we can move 0 comma 1 0 comma 2 or diagonally to 1 comma 1 etc. All are safe here because all the numbers are 0. We don't have one, that is trap basically, right? Here for this particular example we will continue moving, visiting all the safe cells, finally reaching 1 comma 2. Suppose consider we can move one step at a time, right? So as we are making use of the DFS, so suppose let's say we'll move right? So we'll move to this one and finally we'll move to this one. It is possible, right? So this is the path. Suppose you can just go bottom and from here, and also you can reach, or you can just move diagonally and you can reach, right? This is the minimum actually. Diagonally, if you move here, this one, and you can just reach this one in the 2 steps itself, right? So this also you can do. You have plenty of ways to reach the bottom one, as one doesn't exist at all in the this one grid, right? So here we continue moving, visiting all the safe cells, finally reaching 1 comma 2, nothing but the target cell. Hence the output that we get here is yes. Hence the output that we get here is yes. Same thing, this is in the theoretical part. So we'll start at 0 comma 0 first row, first column. We'll move to 0 comma 1 0 comma 2 or diagonally to 1 comma 1 etc. All are safe here. We continue moving, visiting all the safe cells, finally reaching 1 comma 2, the target cell. So I have showed the same thing. Don't need of that much of theory. So the output is quite obviously yes. The output is quite obviously yes. We will be making use of the backtracking, nothing but the DFS from 0 comma 0, trying all the 8 directions as I have said, right? So marking visited. Once we have visited this cell, once we have visited this cells, we will mark this one. Will mark this one. I have just given so suppose this is the route that we followed, right? First we will be starting with this one. We'll mark this cell. After visiting this cell we mark this one. After visiting this cell we mark this one. After visiting this cell we mark this one, and we end the DFS here as we have found the last cell, nothing but the 0 is present here, right? As we have found the last cell. So this is possible. So whenever we enter particular cell, we mark that one as visited so that we don't have to revisit that cell again, right? So that is the reason we'll be marking this cell as visited. So I have just given M for the marking, so you can just consider X or something, right? Anything. So I hope this part is completely clear, man. So we have got the output S here. As we can reach from the first cell to the last, the output is S here in this case. The output that we got here is S, which is equivalent to the output that they have mentioned for the input 1 in the example within the question, right? So our approach works absolutely correct in this case, right? So now let's discuss the complexities very quickly. Let's discuss the complexities very quickly. So what is the time complexity here? The time complexity would be big of 2 into n. The time complexity would be big of 2 into n, right? So what would be the space complexity here? The space complexity would be big of 2 into n as well. So the time complexity is big of 2 into n because we are visiting the each cell here at most once during the DFS. We are visiting each cell at most once during DFS. So overall time complexity would be 2 into n, as we are going with the backtracking as well, right? So it would be 2 into n, and the space complexity would be 2 into n because we are going with a grid and visited arrays. We are, or we will be going with a, sorry, we will be going with a grid and visited arrays. We have to mark visited, right? Once we reach that particular cell, or once we'll be considering that particular cell, we have to mark them as visited. So here we'll be going with grid and visited arrays. So the space complexity would be big of 2 into n as well. The time complexity and the space complexity for the code that we'll be writing in the future would be big of 2 into n, right? I hope the complexities part is completely clear. Now as we are completely familiar with the complexities and the approach part, so we are good to write the code. Let's start writing the code. So let's start writing the code. I'll just come to the compiler here. So we'll be making use of the fast input and fast output. Let me go with here. So I'll just go with, or let's import the input output package here. So this is fine. So let me go with a class and name the name. So I'll just name the class main. This is fine. So within this one, let's go with the first number of columns, right? So I'll just go with, yeah, static int n. This is fine. The next step is, let's go with the 2D grid representation of the game. We are going with the 2D grid representation, right? So let's go with the 2D representation of the game. Here nothing but static, this will be char, and this will be grid. This is fine. The next one is we have to track the visited cells to avoid the cycles. This will be static. So this will be boolean. Yeah. So just give me a second. So let me consider the variable name visited. Let me consider the variable name visited. So let's go with the 8 directions, right? So this may be north, northeast, east, southeast, south, southwest, west, and northwest. These are the 8 directions that we'll be going with basically, right? So this will be uh, we have to go with the change in row and change in column. Two things, right? So we are going with the 8 directions, nothing but 8 possible directions. As I have already mentioned the directions, right? So here um, we can go diagonally as well. That is the reason we have to go with this one, 8 possible directions. So here in this case, first let's go with the change in row. So I can write in this way, static int. So this one will be dx, this will be -1, -1, -1. So this will be 0, 0. So it's 5, right? So we have 3 more. This will be 1, comma 1, comma 1. This is fine. Yeah, let me copy the same thing and make the necessary changes for changing this one column. So let me copy this one and paste it over here. So instead of dx, I'll just consider here dy. This is fine. This is -1, 0. This is 1, and this will be -1. This one will be 1, and -1, 1. This one will be -1, 0, 1 is there, right? -1, 0, 1, -1, 1. This is fine. 5. -1, 0. This one has to be -1, and this has to be 0, and the final one is 1 itself. This is nothing but the change in column. So the next step would be we have to we as we have discussed this one earlier, we will be going with a backtracking DFS from the cell x comma y. So we'll be going with a backtracking DFS from cell x comma y, nothing but from the first, this one from the first cell, top left cell, right? 0 comma 0 in our case. So I'll just go with here main. So this is fine. Let me remove this one, or we are going with a this one, right? BFS. So just give me a second here. Mm, let's do one thing. Oh, this will be the helper method basically, right? As we are going with a backtracking as well. So I'll just go with public static. So this one will be boolean. We have we are going with a backtracking DFS, right? So I'll just name this one backtrack. So this one will be int x comma int y. So this is fine. So within this one, what we'll do, we have to go with the we have to reach the destination 2 comma n. From 1 comma 1 to we have to reach the destination 2 comma n. So if we are able to reach the destination 2 comma n, then we have to return boolean value true in that case, right? So the output is in the form boolean value, yes or no. So if we can reach the destination, then we have to give the return value true. I can write in this way, if x equals 1 according to with the direction we are going, right? So 1 is nothing but the trap here, and y equals this one, we are comparing the value, right? So the last cell, nothing but n minus 1 here in this case. In this case we have to return true. In this case we have to return true. So and also we have to mark the current cell as visited. After visiting the particular cell, we have to mark that one as visited. We have discussed this one in the this one, what do you call, approach. So this one is visited of x comma y. Let's assign this one to true. This is fine. So we have to explore all the 8 directions. So let's go with the for loop. Let's go with the iteration part now. This will be for int d equals 0, d, sorry. So this will be d equals 0, d less than 8. So let's go with the d plus plus. So as we are exploring all the 8 directions, I have considered here 8. So as it starts from 0, this will be 0 to 7, right? 8 directions. We are exploring all the 8 directions here. So we have to move to the next row and next column. So this will be next, for the next row I'll consider nx. This one will be x plus dx, x plus dx of d. So why did I, okay, dx of D. And also we have to move to the next column, nothing but in this case, this will be ny equals y plus dy of D. This is fine. So the next step is we have to check if it is within the grid bounds. Means it shouldn't go out of bounds, right? So that is one of the edge cases as well when we are making use of the DFS along with the grid. So here in this case, I can write in this way, man. If nx greater than or equal to 0 and nx less than 2, and we have to consider ny greater than or equal to 0 and ny less than n. So then what we will do? So we will only visit the unvisited and safe cells. Means let's go with the if condition here. If not of visited of nx, this one will be ny, then and again let me type this one instead of copying this one again, nx grid of ny. So we are going with the comparison. So here if it is 0 within the strings, right? So I'll just give 0 within the strings, right? So then what we have to do, we are going with a backtrack. So if backtrack of, we have to consider nx and ny, right? So nx comma ny, nx and ny are nothing but the next row and the next column. We have to explore next row and next column. Next row is nothing but the nx, ny is nothing but the next column. So in this case we have to return true. If all the if the path is 0, then we have to return true, right? So this is fine. So we are done with the we are done with the code for the backtracking or the helper function here. So if no path is found from this cell, from the particular cell, then what we need to do, we have to return false in that case. So I'll just give here return false. This is fine. So let me come out of this one entirely. We are done with the helper method. So let's go with the main function now, main method, right? So I'll just go with here main. So here let's go with throws input output exception. This is fine. So here let me delete this one entirely. So within the main function what I'll do, so let's go with the fast output, I mean fast input and fast output quickly. So I'll just go with buffered reader. This is input output part. So this will be br equals new buffered reader. So new input stream reader. So this one will be considering system.n, right? We are making use of the inbuilt ones, right, for the fast input and the fast output. So for the fast output I'll be making use of the print writer. So this will be print writer put equals new, this will be print writer of, this one will be system dot out. So this one will be system dot out. So the fast output. So the next one would be the number of test cases. So this will be t equals integer dot parse int. So this one will be parse, and so this one will be buffered reader dot read line. So this one will be read line. This is fine. This one will be read line. So let's go with the while condition here. So means test cases, when the test cases this is greater than 0, then what we have to do, we have to read the number of columns, means we have to go with number of columns, and we have to create the 2 into n grid as well. First let's do that. Let's go with the number of columns, nothing but let's assign n to integer dot percent, this one buffered reader dot uh I have written read line, right? Oh, this has become line. So we have written read line. So yeah, why, that is the reason it was not showing here. This is read line. So we are going with the number of columns, and also we have to create the 2 into n grid. So for that one I'll just assign the grid to new, this one char of 2 into n, as we are going with the this one 2 into n grid. This is fine. This is fine, easier to understand, right? So let's reset the visited matrix. We have to reset the visited matrix, right? So we should, we shouldn't revisit the same cell. So that is the reason we are making use of the visited variable here. So we have to reset the visited matrix here. This will be new boolean of 2 comma n. So this will be grid of 0. Let's assign this one to buffered reader dot read line, this one to char array to char array. This is fine. uh, Let me go with the same thing for the grid one as well. So here let me copy the same thing and let me paste it over here. So instead of 0 this will be 1, and br dot read line, so this one will be to char array. This is fine. So now what shall we do? Let's start the DFS from 0 comma 0 and check if we can reach 1 to n minus 1 or not. So I'll just go with the print line. We have to read each line, right? So not only the this one horizontal part, we have to read each line by line. So that is the reason we'll be making use of the println here. Either you can go with the system out println, or this is faster, right? So as we are making use of the this one buffered reader and print writer, so we can just go with the println here. So we will be making use of the backtrack from 0 comma 0 from the first cell, if you remember, right? So if we can reach to 2 comma n, then in that case we are making use of the ternary operator. In that case we will be returning yes, or else we have to return no, or else we have to return no in that case, right? So finally what I'll do, we have to flush the output buffer, nothing but here in this case out dot flush here. This is fine. Out dot flush. So this is it for the code. Now before checking the code with the different inputs, I just have to copy paste the signature starter template, right? So let me copy paste this one, signature starter template. Just give me a second here. So here let me come here, let me paste it over here. So here, just ignore this one, just concentrate on the logical part. So I'll just come here, let me copy this one, and we have to get the output double s no s, right? So I'll just come here, let me paste this one over here. So we are getting the output name as a symbol variable nb as one, line number 49. We haven't made use of the nb nx and ny, right? So where is 49, line number 49, while this one, so this is just n, right? So let me run this one again. So now we are getting the output, this one double s no s. So here this was the problem basically, right? So this is fine, we are getting the correct output, right, for all the inputs, 4 inputs we have. All right. So now let me do one thing, let me copy this one entirely and let me paste it over here. We have already selected a, the problem name is computer game, which is a, right? So this is fine, let me submit this one. I hope this works for all the test cases, man. Let's see. So let's wait for some time. Running on test case one, test one. So why this is slow here? Still running on the test one. Stuck at running on test one. Let's wait for some time. Let's wait. Let's wait for some time. So you can clearly see here the code got accepted, right? So the code got accepted. So whatever the code that we wrote works for all the test cases, right? So I hope the solution part is completely clear along with the approach and the complexities. For now, this is it. Thanks for watching, guys.